Hello everyone, I'm Haricharan and today we'll be looking at the video editorial for Codeforces round number 844, and in this I was able to solve problems A, B, C and D. So we'll start by looking at problem A and that's called parallel projection. So if you read through the question, it says the following thing. You can pause the video and read the question. So the question is basically, what is the minimum length of cable that can connect the laptop to the projector? So to summarize the question, you actually have the laptop at some point A and B on the floor, and you have a projector on some point F, G on the ceiling. And what is the minimum length of cable? And you can only put cables on the walls and the ceilings. Now, let's think about the solution for this. So if you think about this intuitively, you can already see that if you want to go from here to bottom, the height h will be added always. So this height is the h of the room. This will be added always, so that doesn't really matter. That will get added anyways. That is because if you are going in some path to the wall and then you are going downwards with some h height and then you are going back again, this h will get added anyways. And you can also observe that you can always go downwards in a height of h and you won't need to add any more to this. Now let's think about this. The shortest distance would actually be if you were to move to any four of the edges. So you can move from here to here, here to here, here to here, or here to here. Now I'm saying this would be the shortest distance because if you say if there was some other shortest path, now there are multiple shortest paths obviously. I mean there could be multiple shortest paths. Now some paths look like this, for instance. Like this, for instance, you could actually shift around this line, like this line which I've circled over here. You can shift around that line to the right. So the point is that you would always move like basically like along the same x and y axis as this point F, G is. Based on this, you can move in any of the four directions, and we just have to take the minimum of the four and like we have to calculate the distance to A and B. So if you consider this to be the origin, say, you can conclude that this will be of length W and this will be of length H. Length D. So based on this, if you were to go to any four of the directions, say you choose this particular direction, let's think about what a total length travel would be. If you think about this particular distance would have been F, right? This distance would be F, and then this would be H. And then if you think about this distance, this particular distance, this piece would be A again. Now this piece would be G minus B in this case. But G minus B is actually for this particular diagram. Say if the point A comma B was somewhere over here, then it will actually be the absolute value of F, J minus F. So point being, for this path I have shown over here, the total distance would actually be F plus H plus A plus the absolute value of G minus F. The absolute value of G minus B. So this is one particular path, and based on this you can actually do for all four of the directions. So say if you want to do it like say this particular direction, let me choose a different color. If you want to choose this particular direction and you want to go like this, in that case actually your path would be, instead of F you would just have like W minus F over here. So it will be W minus F plus H. That's because this entire length is W and this particular length is F. So this will be W minus F. So it will be W minus F plus H plus W minus A plus the absolute value of J minus B again. And of course you could also do this on these two directions also. In this case you just have to interchange F and G and interchange A and B, and you will get the final answer. And of course the minimum length of cable would be the minimum among all four of these cases. So I'll just show you through the code also. So if you have a look at this code over here, I have some other extra things which we won't bother about here. Let's just look at the solve part. So we just have our W, D and H, that's the width, the depth and the height of the room. We also have A comma B and F comma G, that is actually the position of the laptop and the projector. And based on this, the answer would be the minimum of all four of the things I talked to you about. So this F plus H plus A plus absolute value of B minus G, that is basically this thing over here. And then you also have this thing, and you have some for the other two also. Based on this, you can just output the minimum of this, and you can see that actually this is passed. Now let's have a look at the second problem. The second problem is also a very interesting problem. So the problem, you can pause the video and read the question if you want. So there are n people who are planning to visit the cinema, and every single person can either go to the cinema or not. And that depends on how many other people will go. This is actually very interesting. So let's think about the fact that a person I becomes sad if they go to the cinema and less than A other people go, and if they don't go to the cinema and at least A other people go, they'll become sad. I mean, how many ways can a set of people going to the cinema be chosen such that nobody becomes sad? Okay, so let's think about this. First thing is you have some input array here, and if you have some input array like this, in general you can just always sort the array. This is because we are trying to choose the people, so you might as well sort the array because the order in which the people are chosen doesn't matter, so you can just sort the array. Now I have sorted an array, so let's have a look at this particular case, 2, 1 and 1 here. So I'm trying to solve problem B here, and problem B, actually the input is 2, 1 and 1. So that means if you take this person, if this person goes to the cinema and less than A other people go, that means if say this particular person goes to the cinema and less than 1 people go, they'll feel sad. That means if this person goes, then this person also has to go. That means one particular option might be both people going. So that's the first part. And then also they'll also become, actually they'll become sad if they don't go to the cinema and A other people go. So if say the first person doesn't go to the cinema, actually they'll get sad if the second person goes to the cinema. So to prevent that, second person also shouldn't go to the cinema. So if neither of them go to the cinema also, that's a valid solution. This is just a very simple case. Now let's look at a more interesting case. So the problem is now I have some sorted array, like this. I have some sorted array over here. Yeah. So I have like this particular array over here, and now the problem boils down to something like very interesting. So we want no one to become sad. That is, every single person has to be happy. That means if strictly less than A people go, then they'll be sad. So basically, greater than or equal to A people have to go to the cinema if a particular person goes to the cinema, and if a particular person doesn't go to the cinema, and then basically less than or equal to A people have to go to the cinema. Now let's think about this. We have some sorted array over here, and actually I'm just going to take the case of this example over here because I think that's a very nice example. So if you write the array in sorted order, that will just be 0, 2, 3, 3, and we have 6 and 6, and we have 7 and 7 also over here. Yeah, that's, we don't need these two things also. Now the point is we have this sorted array over here. Now let's think about this array. The basic observation is that say a person with a particular AI goes, and say actually let me take a different index. Yeah, I'll take this index over here. Say this person goes and this person doesn't go. Now if this person goes, and that means he should be happy, right? And if this person goes and he is also happy, that means strictly less than A other people go. So that means if this person goes, then strictly less than 5 people have to go. That just boils down to saying strictly less than, sorry, strictly less than 6 people have to go. That is, less than or equal to 5 people can go. That is completely fine. Now based on this, now say this person goes and like this person doesn't go. If this person like does not go, that is the person with A value 7, that person doesn't go. Actually he'll become sad if say like he doesn't go to the cinema and 7 other people go. So if say 7 other people go, then he'll get sad. So basically this person will be sad if 7 people go. That means like only 6 people have to go basically. So for this particular index, only 6 people have to go. And that also means that actually if this person does not go, anyone else to the like basically anyone else to the right of them also cannot go. Like for instance, we'll just make a breaking line kind of here. So if you take this particular index, anyone else to the right of this particular line, none of them can go. So like say for instance, like this person of index 7 can't go. Actually that so now the person of index 7, like the person with A equals 7, that person can't go. That means any person to the right of them cannot go. So all that means is, like if they don't go to the cinema and other people go, they'll be sad actually, right? And since we don't want anyone to be sad, anyone to the right of them cannot go. And the same logic applies for this person also. Say this person goes to the cinema, everyone to the left of them has to go to the cinema. If everyone to the left of them doesn't go to the cinema, like they'll all be sad basically, for the reasons I mentioned before. So now the point is this: we have some sorted array, and in the sorted array, okay. So we have this particular sorted array over here, and in this sorted array, what we have to observe is, let's think about the points where we can break this array. Okay. Also, let me just finish off the above example. So you can break the above array over here. That means only the person 0 will go. Only the person with a value 0 will go. So actually, all that means is, if he goes to cinema and less than a other people go, he'll be sad. So basically, greater than like greater than or equal to 0 people go, he'll be fine with that. And here actually one person goes, so he is actually fine with that. And then also, if you think about all the other people, if they don't go to the cinema and then at least a people go, they'll be sad. But so that means if at least 2 people go, this person will be sad. But actually 2 people aren't going here, only one person is going. So all of these people will be happy. So the thing I have shown here, that is actually a correct way to break this. But of course, actually this isn't a correct way to break this. This particular thing, that isn't a correct way to break this. And also one more way where you might want to break the array would be actually over here. That means because everyone to the left of them, they all can go actually. But everyone to the right of them, they cannot go. Also, let's look at another very interesting observation, is that a is actually less than or equal to n minus 1. That means if all the people go, that always works, because all the a's are basically less than n minus 1. So if you take all the people, that means basically they go to the cinema and strictly less than a people go, they will be fine with that. So basically, if strictly less than n minus 1 people go, if strictly greater than n minus 1 people go, they will be fine with that. If strictly greater than or equal to, like basically if greater than or equal to a people go, they will be fine with that. And because of that reason, taking everyone is always fine. So basically, you can always take all people and they will be completely fine with that. Now let's actually look at the proper solution. We have to find the breakpoint, right? And we have to find the breakpoint in O of, we have to find all the breakpoints in O of n time. That means we have to find one particular breakpoint in O of 1 time. Now assume that the breakpoint is over here. Now based on this, let's think about the array to the left and the array to the right. So if the array to the right, so you can see that it has index 3 here. In general, assume that this index is I and this index is actually I plus 1. Now if the index is actually I, that means before them, by the way, I'm using 0 indexing over here, if that wasn't clear. Actually in the question they have like one index, but in my solution I have actually like 0 indexed it. So before them there will be I people, okay? And of course the person in the ith index, this person would be going and this person would not go. And based on this, let's think about this. So there are I person before him, and if they go to the cinema and strictly less than a people go, they'll be sad. So basically greater than or equal to a people go, we'll be fine with that. So basically that means the number of people who go, like the number of other people who go, total number of people who go would actually be I plus 1, but the number of other people who go would be I, right? So all this means is we actually have a first condition here, that is if strictly less than a people go, we'll be sad. That means definitely greater than a people have to go, greater than or equal to a people have to go. That means a has to be less than or equal to I. And based on the same logic, if you take this particular index over here, you can clearly observe that I plus 1 other people are going, and actually this person will be sad if they don't go to the cinema and at least a people go. That means actually the number of people who go has to be greater than or equal to a basically. So that means I plus 1 has to be less than or equal to a plus 1. So based on this, I'll just show you my solution here. Yeah. Right. So that's my solution over here. So basically, when a particular index is valid, is that I plus 1 has to be actually strictly less than a plus 1. Yeah, it has to be strictly less than a plus 1 actually. So when both of these conditions are valid, we can actually increment our index. So if you look at my solution over here, again as I told you, just sorting the array. We are initializing the count value to be the entire, like basically that to be 1, because taking all the people is always valid. So count is initialized to 1 because taking all the people is always valid. We have a small condition over here. If a0 is not equal to 0, count plus plus. That actually means if the 0th element is not 0, that means there are no 0 elements because it's a sorted array. That means it starts with say 1 or it starts with 2 or something like that, right? That means taking 0 people is also fine. So that's why we are doing this particular check here. This check is to ensure that taking 0 people is also accounted for, and that's fine. Now we just have for loop over here, and this is the condition I mentioned about. We should not increment whenever I is less than ai or I plus 1 is greater than or equal to a plus 1. And in all other cases we have to increment here, and we just have to output count. And you can see that my solution has been accepted over here. Now let's look at the third problem. Third problem is actually a very nice question. So we and it also has a slightly complicated solution, as in the implementation is very hard. So you can read through the question if you want. Yeah, right. So now let me continue with the solution. So the problem is basically this: we have some array, and we have some string, and we want the string, all the characters in the string to appear the same number of times. And if they're not appearing the same number of times, then we basically have to change the array such that it appears the same number of times. I think this will be easier if I simultaneously show you my solution also, so that we can understand it easily. So I have a solve function here. Again, I'm just taking n as input, the string as input. I start off by creating a frequency array. This of course, creating a frequency array is like very common thing to do with whenever you have any strings, and that's exactly what I'm doing here. This is a frequency array containing numbers from 0 all the way up to 26, in which I'm storing how many times all the characters from A, characters all the way A to Z appears how many times. That's my frequency array, which I'm calling ARR here. Now let's look at my solution over here, in which I'm sorting this array first. I'm actually copying that into another array called B, and I'm sorting the array B. Now B is a sorted array, and it's sorted in reverse order. Now let's first think about the fact that if you make every character the same, that solution is always valid. Like for instance, if I have the array Codeforces, for instance, or the string Codeforces, if I make every single character like C, that solution will be always valid. So that's like basically one solution which is always valid. But of course that might not be the best solution, obviously. So what I'm doing is I'm iterating over how many unique characters are present in the final solution. So the final solution, they might be like just one unique character. That means all the characters are the same basically, or they might be all the 26 unique characters. Now n modulo I has to be equal to 0. That's because if n modulo I was not equal to 0, that means of course we can't have like I characters repeating themselves. So n modulo I has to be equal to 0. I have two quantities called G and F here. So basically we'll think about what these things are. I have a sorted frequency array called B, right? So initially we had a frequency array called ARR. I sorted that and I got this array B. Say if we take the array, take the array Codeforces. Here in this case the sorted frequency array would be 2, 2, 2, 1, 1, 1, 1, and then everything else will be 0 basically, all zeros. Now let's think about this. What all might be the possible values of I over here? And since n is equal to 10, I can only have a couple of different values. I can be 1 as I told you, I can be 2, I can be 5, or I can be 10. So basically you can have all 10 distinct characters. That's completely fine. That's a valid solution. You can have 5 distinct characters, even that's a fine solution. You can have just 2 different characters, that's also completely fine. And you can have just one distinct character, that means all the characters are the same basically. We have this many 4 solutions we have, and now we'll think about all the 4 solutions. So one more observation is that say I'm choosing this particular value in which I'm having 5 distinct characters. So if I'm having 5 distinct characters, that means each character occurs twice. So this character is occurring twice already, so I don't have to touch this at all. This character is also occurring twice, I don't have to touch this at all. This character is also occurring twice, I don't have to touch it at all. This character is occurring once, this character is also occurring once. This character is occurring once, this character is also occurring once. That means we have to change all of these characters. And we'll think what we have to change it into. So if you look at the character that occurs once, they're basically D, F, R and S, right? So we have D, F, we have D, F, R and S over here. Now, if we were to replace an R to D and an S to F, we'll be done basically, right? Our solution is done basically. Because if I replace an R and D and I replace an S with an F, that means we'll have 2 of this, and then 0 of these things. So basically that means we'll be done with the problem. So here in this case the answer would be 2 actually, but of course that might not always be the best. Now let's think about a different frequency array in which all the array elements are 3, 2, 2, 1, 1, 1. Yeah, we'll take this example. So this might be for something like, say, something like this. So here the character C occurs 3 times. Clearly you can see this will be the frequency array for this particular case. Now in this case, again if I were to choose my my I value would be like say my I value is 5 again. If the I value was actually 5, that means each of these have to be 2, right? I have to try and make all of these to be 2. And the way I can do is I have to decrease 1 C actually. So I have to kill this 3 and make it a 2 actually. That means I have to replace a C. No, I have to replace a C. These 2 characters I don't have to touch, they are completely fine. And then like I have to increase these characters. Also that I have to like basically make these characters also 2, right? That means I have to I might have to kill this one, and then I might have to replace it by a different character. Now the point being, I might have to replace 1C into one of these characters, and then I might have to replace this character into this character. And if I do that, I'm done, and I can do it in 2 operations. And again, that's the basic idea. Now actually what will be the number of operations you need if you choose a particular value of I? I've chosen a particular value of I. That means that particular character will occur n over I times, right? And we want each of the array elements to be n over I. That means what we have to do is the following thing. So if a particular index is actually greater than n over I, like say for instance here 3 is actually greater than n over I, that means I have to subtract or I have to remove that that particular letter from our total, right? That means I just have to remove this or remove one of these actually. And also if some element is actually less than n over I, that means I have to add it up. So I have actually 2 variables, g here, f here, and here what I've done is if b over j minus n over I, if that's actually positive. If that's positive, I'm just adding it to f, and if that's negative, I'm adding the absolute value to g basically. That means if b over j is greater than n over I, I'm adding it to f, and if n over I is greater than b over j, I'm adding it to g. Like that means basically the variable f that will store all of the excesses. So in this case, actually the variable f would be something like 1 over here, and in this case the variable g would be 3. For the case I've shown above, f is 1 and g is 3. And clearly you can see that what you can do is you can do some very interesting replacements. So you can replace one of the characters here by this character, and you can replace these 2 characters also. The point being, also one more thing I have to remark is that you are allowed to have only 5 characters, right? Like we are only allowed to have the first 5 characters, and all of these characters we just have to discard. So we have to replace all of them. You have to make all of them 0 anyways. So the point being, in the first I characters, I actually have to make them n over I, and the remaining characters I just have to make them 0. Based on that, I just have to calculating what all indices I have to remove essentially, and what all indices I have to add up, and I've stored them in 2 variables f and g. Now the number of calculations that I have to do, that will actually be the absolute value of f minus g, that's c linked over 2, plus the minimum of f and g. And I'll try to explain this to you. So all the elements which are excess basically, those are f, right? And all the elements which are like less, those are g. I have to change all the f's to g basically. That's sorry, not the f's to g. Basically I have to change all of these elements. But what I could do is actually I might have to change some of the elements of f, and I have the ability to change them into the elements of g. So like for instance, it's completely fine, as we did in the above example, to change one of the c's into say one of the d's. That would have been completely valid, and because of that reason we are allowed to move some of the elements in f to the sum of to the elements in G. Because of this advantage, you have to do minimum of f comma g operations anyways. That is because these operations I told you, and whatever is left over, this minimum of f comma g, that is because I have to do all these changes, and whatever is left over, I can just take the absolute value of that. Basically, absolute value would be whatever is left over. Leftover thing would be absolute value of f minus g. I can pair those up. As in I can just change one into another. Because of that, actually I have to divide this by 2, or it will be ceiling division. So this is how many operations I have to do. And this solves the first part of the problem, in which they have actually asked for the basic number of operations you have to do, the minimum number of operations. Also, I'm based on this, I'm just also I have to specify that I'm iterating over I here. So I'm just iterating over this 26 times for all possible values of I. Whichever one is valid, I just use that. I hope that's clear. So based on this, we can see that I'm just iterating over that here, and whenever I'm getting a minimum value of I, I'm just storing that in a particular index called min index. So min index is basically how many unique characters we have in the final solution, and then ans is how many operations I have to do to achieve that. Now I told you about more and less, right? More and less are two sets I've created here. Si is my definition for a set actually. Based on this, I'm just iterating over this array. So I'm just iterating over this, because the issue is I have this frequency array, right? Actually, this array is a frequency array, but that frequency array doesn't have any character information. This is probably a bit of bad implementation, but anyways, we'll stick with that. So the point is, this is just a frequency array, and I actually don't know what particular character was repeated 3 times over here. So in general, instead of C, this could have been like, say, some other G or something also. So to avoid that problem, I'm actually trying to find what basically what character this 3 is. And in this case, this 3 actually was a C, right? If I have the array this particular array, this 3 was a C actually, and this 2 was an O, and this 2 also was an E, and so on and so forth. Based on that, I'm just trying to find that here. That's what this array does. And also, let's think about this more and this less over here. More is again very straightforward. It's very intuitive, I think. Like whatever characters, they're basically greater than n over I. I'm just putting them in a set called more. And then whatever characters are basically less than that, I'm just putting them in a set called less. And then that part we have over here, I'm just outputting the total number of operations over here. Now I'm just iterating over the entire string, and now what you can observe is, if a particular, so let's look at the original frequency array also. Now C would be basically what character that is, and if the Cth element of the array is equal to n over ff, I don't have to touch it at all. I don't have to bother with the array at all. I can just continue, and I can just remove that. Now based on this, if I can continue, it's fine. Otherwise, I'll just go to the next index. Now I have to change a particular element in 2 situations. Either it could be more, or it could be not more and not less. All that means is, let's think about what all characters I might have to change. So I have to change a character definitely if it's more. If a character is more than how many times it's supposed to appear, I definitely have to remove this. So then I have to remove characters like this. Also, if a character appears less, but actually, so basically these 2 would be less, right? So if I take the above array, I'll just rewrite it over here because it's a bit clumsy over there. If all zeros over here. Actually, if I what all characters would be in more would just be C. So my set more would just contain C, and my set less would contain these 2 characters. And based on the above array, I'll just choose it to be D and R basically, D and F. I'll choose it to be D and F to be more accurate. Now, if a character neither belongs in more and it doesn't belong in less, that means it has to be this character that is actually R. And I do have to change this R. I definitely cannot be with this R. So I just have to change this. So whatever, it could either be a character in more or it could be a character in less. I just have to change it to one of the characters which are in less actually. If character is more, I have to change it to character in less. Or if character is neither in more nor in less, even then I have to change it. So that's what this particular logic implements over here. But we have to keep in mind that this set less over here, actually initially the set less would contain D and F only, right? It would consist of these 2 characters. But we have to observe that sometimes as we keep adding more and more D, like say I want to replace the C by D. Say I want to replace the extra C by a D, then actually what might happen is this might become 2. Basically that particular list might be 2 and it might not be less anymore. In that case I have to delete this from D. That's what this particular logic is doing over here. It just basically if basically the frequency of a particular element in less, or the frequency of the first element in less in fact, that becomes equal to n over ff, I just have to erase that from the set less. And based on all of this I'm just finally outputting the string, and you could see that it actually passed. Now let's look at problem D also. Problem D is again a very interesting problem. I'll leave you a second to read the problem. So we are given some set A and we define the squareness of the integer x as above, and we want the maximum squareness among all integers x between 0 to 10 to the power 18, both are inclusive. So let's rephrase the problem. We have some given array, and the first thing you have to notice is again it's always fine to it's a sorted set actually. It's more like a set than an array, but anyways, the point being we can just add up whatever x we want. So yeah, we have some array over here, and we can just add up whatever we want to that. So I have to add some x to each and every element here, and I need to obtain the maximum number of perfect squares. So the basic problem is this: I have to add up some element x and I have to obtain the maximum number of possible squares. And so the solution for this is again very interesting. You have to notice that we can always make one perfect square, whatever array I have. Also there is a small edge case over here. If n is like 1 over here, that means my final solution will be 1, because I can always make it a perfect square. That's completely fine. I can just choose the appropriate value of x such that it becomes a perfect square, so that's completely fine. Now we'll just look at this particular problem over here. So I have this array over here, n is greater than 1, and I have to add some like integer x to all the elements of the array. Based on this we'll see what happens. So the point is this: it's a sorted array. So let's think about this. Say one might be possible. Now we might have 2 perfect squares. Now I'm saying, let's say we have 2 perfect squares. If we have 2 perfect squares, can we find what those have to be? So one very important observation here is, let's think about perfect squares which are like 1, 4, 9, 16, 25 and so on and so forth. You might have known that the difference between perfect squares are consecutive odd numbers. So these are like 3, this is 5, this is 7, etc. This is 9 actually. Also the difference between these things are actually numbers of the form 4 and plus 4. So difference between this is actually 8, this is this is 12, this is 16 and so on. And likewise you can just keep doing for all of the cases. Here actually it's like 15 and so on and so forth. Actually in this case it's actually the point is you can just like keep on like doing that here. In this case it will be 3n plus 9 actually. Now the point is this: we have n elements in the array. You can notice that n is very small here. That's actually 50. That means you can do something like a O of n cube algorithm also. That's O of n cube n to the power 4. Anything will be fine. So like that doesn't matter. So based on this, the solution is like this. Since we are adding this element x, we actually want to like get rid of this x. So because of that idea, we'll just subtract all of the elements in the array. So since we have n elements in the array, there will be nc2 subtractions. But of course we just want actually the absolute value, so it will be somewhat like easier to subtract. But anyways, the point being, we have to do a certain number of subtractions over here. So I'll just take a particular example. Say this 1, 2, 3, 4, 5. So we want this 1, 2, 3, 4, 5. If you think about all the differences between all the various elements, they're actually 1, 1, 1, 1, 2, 2, 2, 3, 3 and 4. So like that's the basic idea over here. We have 10 different possible subtractions. Now let's think about this. If you have a bunch of perfect squares which are like 1, 4, 9, 16, etc., we can notice that all the subtractions, if you have a bunch of perfect squares, they actually belong to a certain set. If you have like 1, 4, 9, 16, you can't have any arbitrary subtractions. All the differences have to be like, either they could be odd numbers 3, 5, 7, etc., or actually they could also belong to the set 8, 12, etc., and so on and so forth. But of course, if we can actually cross verify between these two sets, we can just check between these two sets you can see that, that basically the only common element they have is 3. This 3 over here. And this 3 also is actually the difference between 1 and 4. Also, it's the difference between 2 and 5 also. We'll come to that again. But the difference between 1 and 4 is actually 3. And we have all the possible differences written on the left. And the only common elements between the set on the left and the set on the right is basically just 3. It's one thing. Also, let's think about one more interesting thing. If you want to add up 3, or rather if you want a difference of 3, what should you add up? As in, like here we have 1, 2, 3, 4, 5, right? Between these two elements, like say these two elements would be in the final perfect square set. Like after adding x, say 1 and 4 were there, what should x be basically? And you can clearly see that x has to be 0 in this particular case. Now let's think about another idea, that say x is 0. If x is 0, based on that, we can find how many perfect squares there are in the array. So let's think about our approach again. So if you think about the first approach, we have an O of n squared approach in which we are finding the differences. We're writing down all the differences. We're just checking all the differences in this big set of all differences over here. Like we have one big set of all differences. We're just checking these elements in that. Now based on that, what we're doing is, again we are doing another O of n algorithm in which if we choose these two to be, like if we choose a particular value of x, how many perfect squares are there in the array in total? And of course there would be at least 2 perfect squares, but there could be more perfect squares also, as I told you. So that's the basic idea over here. Now, of course, I have some box things on the left, right? How do I find these? Like, how do I find it was 3, 5, 7, 8, 12, etc.? That's also like very interesting. The difference between like consecutive perfect squares, that will be n plus 1 the whole square minus n squared. In this particular case, it's 2n plus 1, and like those are these numbers. Likewise, the next case would be n plus 2 the whole square minus n squared, which is actually 4n plus 4. That is these numbers over here. And then likewise, if I have n plus k the whole square, that is if you have a number at, if you have the, say the first perfect square and the k plus 1th perfect square, it will be n plus k the whole square minus n squared. That actually has to be kn plus k squared. That actually has to be kn plus k squared. In my solution, actually, give me one second, I'll open my solution. Yeah, so if you actually look at my solution, I called it like L instead for convenience. Instead of k, I just call it L here to stick with the same conventions. So n plus L the whole squared minus n squared, that will be ln plus L squared, right? Now let's look at the final idea again. So we have all the perfect squares. I'm just checking if any of the perfect squares is of the form ln plus L squared. So I have some perfect square. I've called the perfect square num over here. So basically, I'm checking if num is equal to ln plus L squared for some L. But of course, that's problematic because I don't know what L is here. Like I might know what is num, obviously, I can just calculate that, but I don't know what is L. And that is where we are doing one more very interesting thing. And of course, there may be multiple possible values of L also, even that's completely fine. What I'm doing is, I'm just iterating over all possible values of L. So I just have a simple for loop over here. This for loop just iterates over all possible value of L, starting from L equals 1, like all the way up to 2 times. Okay, so like we have this thing, right? We have also this has to be 2L. There has to be a factor of 2 here. Actually, apologies for that. If you have n minus L the whole square minus n squared, it has to be 2ln plus L squared. So basically, num has to be equal to 2ln plus L squared. We want to iterate over all possible values of L over here. That means, what is the maximum value which L can take? That will be when n is minimum, right? And you can clearly see that n will be minimum. Sorry, L would be maximum whenever n is minimum, and n can be minimum, that is just n equals 1. So maximum L, that will occur when 2L plus L squared is equal to num. This will be the maximum value of n you can get. So I'm iterating over all values of L and trying to find a value of n for each of those values of L. So here is what I'm doing. I'm just doing L equals 1, and then 2L plus L squared has to be less than or equal to num, and I'm just like incrementing L over here. Now you can just rearrange this equation to get a value of n if you have value of num and a value of n also. So here in this case, n would just be num minus L squared divided by 2L. And of course, it does divide perfectly. I'm just doing a simple check here that it divides perfectly. If it doesn't divide perfectly and we get like a decimal, obviously n can't be fractional, right? N has to be an integer and it can't be fractional. So we're doing that here. And we have this variable called f. This f is basically what I called n in my explanation. So you can call this f also if you want. So f would just be num minus L times L over 2L. Now, if you have chosen a particular value of n over here, I chose some value of n over here. Now, what should be the value of x? Because finally we want x only, right? And that's actually pretty straightforward. If I have a value of n, that means this particular index, right? That we want that to become n squared actually. So right now it's some particular value. We want that to become n squared. So x would be the difference between n squared and what it is right now. Point being, x would actually be n squared minus ai. And that's what I've done here. X is actually n squared or f squared minus ai. And x can't be negative obviously, because I can only add the value of x. X can't be negative, it has to be greater than or equal to 0. So if x is negative, I'm just continuing here. But if x is greater than or equal to 0, I'm just trying to add x to each and every element, and I'm checking if it's a perfect square. And the way I'm checking if it's a perfect square is using a function called sqrtl and floorl. Sqrtl is for longs because I've actually defined like ints to be long here. So all the ints you can see in my code, they are all longs. If that wasn't clear. So based on that, I'm just checking if it's a perfect square, and if it's a perfect square, I'm just incrementing that. I think this was like a big question. So let's think about the basic idea here. I have two for loops here. What these two for loops do is they calculate all the differences. So num is the value of difference here, and for this num, I'm trying to find a value of x. So the approach for that is I actually iterate over all possible values of L, and then based on that, I'm trying to find like whatever L works, and like if a particular L works, I'm trying to find the corresponding f value for it, or I call it n in my explanation. And after I found a value of n and I've chosen f that works, then I'm just checking how many numbers in the array are perfect squares, and if that works, I'm just incrementing that. And my final answer would be the maximum of all of these things. Keep in mind that my answer would be at least 1, because I can always make one number to be a perfect square regardless of all the other numbers. So that's my approach over here. So yeah, and let's also think about the time complexity of this algorithm, which I still think is very interesting. So we have this thing over here, right? We have 2L plus L squared is num. That's when I break out of the loop. So I have that for loop over there. Actually, I have like two outside for loops. These two for loops will take off, like they will contribute n squared basically. And then if you look at this line over here, num is the difference between two numbers. And if you look at the question, the numbers were like basically, yeah, the numbers were like basically 1e9, right? Because the numbers are 1e9, the difference can be at most 1e9 minus 1. So based on this 2L plus L squared, that means L squared would be of the order root of 1e9. 1e9 is basically 10 to the power 9 if it wasn't clear. I have the question also here. Basically, an can be upper bounded by 10 to the power 9. That means L would be approximately the square root of 10 to the power 9. Let's assume that's basically 10 to the power 5 roughly, right? It's upper bounded by 10 to the power 5. That's good enough for us. So inside that also I have one more for loop here, a third or rather fourth for loop in my solution over here. This for loop is the one which checks actually. So again, this for loop again contributes to a O of n complexity. So if you look at this, I have one big for loop and I have a second for loop. This might have 50 operations at most. Then I have one more for loop for the variable L, which can have like say 10 to the power 5 operations. But this is an upper bound, actually it's somewhat less than that. And then I have one more for loop that can take 50 operations. So if you look at the final answer, that's actually some constant which is approximately 10 to the power 5. It's actually exactly the square root of 10 to the power 9. Solution is actually that times n cube. And you can see that this actually passed. And of course, I had like 3 or 4 wrong submissions before this because of a small error. but now I fixed that and it got accepted. So thanks for staying with me throughout this. Hope you enjoyed it, and I'll be hopefully doing more video editorials in the future. Thank you.